what we're going to be talking about is mapping sagebrush species using LANDFIRE data. And I think in the end, probably a third of you will think that it was almost too simplistic, the approach we took, but that's okay. There's probably going to be at least a dozen ways to skin this cat. So I'm just sharing one of the ways that we have done this for our study. And I wanted to make a quick couple of notes here. Raina, I don't know you, but it sounds like you're in Las Cruces. And I just came from that neck of the woods. I got in pretty late last night, as a matter of fact. I was down working with some people in the Blackfire there, just outside of Las Cruces, not too far, maybe 70 or 80 miles, doing a variety of things. But as you can see, if you look out your window, I'm sure you know that it got really wet, and it looks like all those fires are pretty well taken care of. So glad to see someone on the call from that neck of the woods. And Megan, as far as your toddler throwing a tantrum, I guess we can all say that it's better than an adult throwing a tantrum. So that's okay. Sometimes my dog does that.
Indeed, indeed.
Yeah. Okay, well, let's go ahead and get started after this brief intro and talk about what it is we were after first when we were looking at mapping the sagebrush species. Why did we do it? Why do we want to map Artemisia? And of course, there are many reasons we would want to do that, but by and large, we have a risk assessment project. It was funded by Joint Fire Sciences in the Great Basin primarily. We had talked about expanding that to the entire sagebrush range, but people wanted to focus in a little closer, and I'll show you some maps of what that looks like to the Great Basin proper. And what we were looking at in this risk assessment is combining our knowledge and thoughts of fire probability, the likelihood of fire occurring, and the expected fire behavior that would occur in the Great Basin over a period of time. And we need to combine that with knowledge of values that we care about, of course. We want to understand where values that we care about, such as sage grouse habitat, such as homes, such as infrastructure, critical infrastructure, those sorts of things. We wanted to find out where the likelihood of fire was, higher than other places, and also what the potential impact might be if fire were to occur at those areas where we have values that we care about. And I'm going to throw a few buzzwords out there, and I do assume a bit of knowledge of LANDFIRE resources, as we discussed, Megan. So anyone can just stop me if I use a word that nobody seems to understand. Let me know and I'll explain that to you. So I did assume some knowledge of this. The way we're going to do this risk assessment, we're about 2/3 of the way through it. We're going to use Forces, which is a kind of a decision support tool made by some people in the Forest Service and others to optimize fuel treatments as one of its prime goals of the program, Forces. And that, if you give it the appropriate kinds of inputs, such as expected fire behavior and associated expectations of what happens post-fire. So what's the post-fire response? If we feed the program that kind of information, it can suggest, look, you need a fuel treatment that's 500 feet long, that's 400 feet wide, and you need to do a prescribed fire treatment in this block here or that block there to get the maximum reduction of risk to the things we care about. So it's an optimization program. And one of the major things that we do to help optimize this is using our expected fire behavior post-treatment, of fuel. So if you see the link to the sagestep.org, you can go there, and it's probably one of our best data sets in the United States that describes post-treatment fuel bed properties. And there's a ton of things that are measured, including species response, in terms of what is coming back and what is dying off, but also the structure, how high, what's the height of the vegetation, what's the cover, what's the production. So they're long-term data sets that tell us a good bit about what happens after treatments under a given set of environmental conditions. And so using those data, we're able to suggest for a given, like, let's say, sagebrush site, that prescribed fire would not be a good idea, let's just say as an example, in certain areas because of certain characteristics. Or maybe we ought not to be considering spraying, herbicide, for example, tubitheron or something, to control various shrub species because it does nothing for the fire behavior. So it allows us to evaluate what the post-fire or what the post-treatment effects are on those fuel beds. And all that information gets brought together in forces to tell us where we should be treating on the landscape. So that is just a brief overview of this risk assessment in the Great Basin. Of course, part of what we are trying to accomplish is to protect our core habitats, our core areas of sagebrush. And we can talk about and argue about all day long, discuss what core sagebrush means and why some users, some constituents may have a different viewpoint of the types of sagebrush we ought to be protecting. But that's for another day. Just recognize that part of this risk assessment is to understand how we need to place field treatments on the landscape so that we protect our core sagebrush habitats for all the reasons that that would be a good idea. So in order to protect these areas, we obviously need to know where these sagebrush species exist, because each of the Artemisia species will have different characteristics post-treatment, not only because of the type of species that it is, but the site that it lives on. Is it a cold site? Is it a hot site? Is it a wet site? Is it a dry site? And so with that, we also need to understand what's referred to as resistance and resilience. And specifically, we're talking about resistance and resilience to annual grass invasion. And we have worked very extensively with Jean Chambers and many others. Jean Chambers used to be a Forest Service scientist. She's now retired. But she and members of the NRCS and also many other organizations work together to produce a map that tells us where we see high resistance and high resilience to invasion by invasive annual grasses. And that's predominantly based on the soil characteristics. So we want to know where the soil is relatively hot and dry versus where the soil type is relatively cool and mesic, because that tells us quite a bit about the resistance and resilience to invasion by annual grass. So taking all this together, you can see why one of the key foundations of pulling this off, we want to understand where the different sagebrush species exist to help us place or suggest field treatments on the landscape in this project. Now, I want to briefly mention, I'm doing all this by memory. It's work that was conducted over a set of months. And LANDFIRE insiders, if I say something that seems weird or incorrect, it's totally fine to just jump right in and tell me I got something wrong, because it's hard to keep up. For example, versions. There's many versions of these LANDFIRE data, and to keep up with the latest version is quite important. And so if you see that, well, maybe you should be using a different version for a different purpose, just let me know, because I think it'd benefit everybody.
Hey, Matt, before you move on, we just had a question. Mike asked, how can we access the map you mentioned that Jeannie Chambers and others worked on?
It is available through an NRCS site. I always just get it by calling Jean, so I don't really know, but please have the, I'm sorry, what did you say the name was?
Mike Popejoy. So I will work with him to make sure he gets it via email, and I'll put it in the YouTube description, the link there. So if people are watching the video, I'll put the link in there so people can find it. I'll find it.
Yeah, very good. And just so you know, Mike, that again is just a set. All it is, I'm gonna dumb it down and give you the two sentence version. It's just Surgo polygons, the Surgo soil database, classified based on temperature and moisture regimes of the soil types. So red, green, and yellow, I'm either cool and wet, I have high resilience, or I'm hot and dry, and I'm predominantly Wyoming big sagebrush, let's say, I have almost no resilience to annual grass invasion. So that's really all it is. Jean may disagree with me, but anyway, we'll make sure you get the data you need. Okay, so I want to talk briefly about what we want to do with these data when everything's complete. Well, one thing we're going to do is share them with anybody who wants, the resulting map of the different sagebrush species, because it may help you, number one, to produce a better map. This is our first cut, and I know for a fact there are a good number of inconsistencies because of the way we do it. We do the best we have given our time and money, but certainly there'll be other ways of cracking this nut. So that's one of the main things we want to do, is make this available to people who want to view it and poke holes in it to hopefully improve their own efforts. And again, I am assuming some knowledge of LANDFIRE data and processes when we talk about all this. So what goes into our data sandwich? How do we do it? First, we use the LANDFIRE biophysical settings, the EVT, which is existing vegetation type. And Iana, we talked before this meeting, 10 minutes before the meeting started, about LANDFIRE biophysical settings. That tells us something about, let's just call it site potential. Everyone gets wrapped up in these things, but just recognize it. It describes, as was said, the pre-Euro-American settlement vegetation, or our idea of what that was. Whereas the EVT, the existing vegetation type, tells us what the vegetation is there right now. For example, we might have a big sagebrush shrubland as a site, and that's what would have occurred, let's say 200 years ago. But because of cheatgrass, the existing vegetation type is an annual grass-dominated grassland. So that's the difference between those two products. But also the mapping zone and the LFRDB, or the LANDFIRE reference database. The LANDFIRE reference database is a tremendous asset for anyone that wants to look at vegetation and site characteristics across the United States. In my opinion, it's been such a fantastic effort. I don't think I could do my job without it. So the LFRDB, we take all that information along with information about shrub cover. Now you might ask, well, why don't you use LANDFIRE existing vegetation cover, EVC? We could, and that would be fine. But I think given the advancements in remote sensing over the last 3 to 5 years, there are data that tell us a bit more about the landscape. For example, the Homer et al. Sagebrush cover product, the rangeland analysis platform. There's other data from USGS, from Matthew Riggy, for example. So take your pick. But for this analysis, we used shrub cover data from the rangeland analysis platform to tell us whether or not we thought at a given site or pixel that there was shrubs present in any kind of big way. Because we might think there are shrubs present, like Artemisia species, but if remote sensing tells us over the last 5 years we don't see any shrubs, then we might say, yeah, I don't think there are any sagebrushes here. So no matter what we did before, we're allowing this remotely sensed product from the rangeland analysis platform to tell us, now you got it wrong. There are no shrubs here. Go look somewhere else. And then, of course, we need the USDA plants database. So all this went into our sandwich of how we did it. The USDA plants database is needed because we wanted to understand, of all the Artemisia species in our universe here, which of those are sprouters, for example, post-fire. It's very important. Some sagebrush species are killed, others can sprout. For example, three-tip sagebrush, Artemisia tripartita, can sprout after it is burnt. Same with silver sage, those types of things. Whereas others, for example, black sagebrush, I don't believe has a sprouting characteristic, and certainly not basin big sagebrush or Artemisia tridentata, subspecies tridentata. You're not going to see sprouting on those species. So that's why it's important for us to understand the characteristics and life history traits of the different Artemisia species. And before we get to the maps, I want to emphasize strongly that the approach we have taken, and I'll run you through it, is just one way. There are probably 100 ways to do this, and that's fine. So if someone can get a better way to do it and make a better map, that is a good thing to pursue. Just recognizing there's a million ways of doing this. Okay, this is the broader sagebrush biome, and the yellow is our non-forest domain. The green is our forested areas. The purple is our encroached or afforested areas. We're not going to go into details about this, but this kind of defines our bigger study area that we first started with. But because of the project partners, they wanted to go down a little smaller and just tackle the Great Basin kind of area first. And I'm letting the cat out of the bag here. What we have is a final product from the process. And we're going to spend more time. I've even got a live link to a map. We can zoom in if you would like and take a look at your area and see what you think about the result. But what we have of our targeted species is Artemisia arbuscula, low sage, Artemisia tripartita, three-tip sage, Artemisia tripartita vassiana or mountain sage, Artemisia tridentata, Wyomingensis, and then basin big sage or tridentata, subspecies tridentata in that green. Upper right there is Artemisia nova or black sage. But then we have this ubiquitous mixed category, and we're going to talk about why our process is generally unable to break up those mixtures and discern exactly what species is there. And then finally, the gray is no sage. It could be anything. It could be salt desert scrub. It could be forest. It could be water. So it's gray is off the table. There's no sagebrush there. And we're going to talk more about this. Don't worry. I wanted just to give you a brief flavor and an intro before we dive in a bit more. This is a zoom in on the map here in the Snake River Plain, but towards the east end of that domain. What we see is on the valley floor, the green color, that is the tridentata, Artemisia tridentata, Wyomingensis, and could be mixed with tridentata, or basin big sage. That's on the green, the valley floor. Then we kind of move up the hill a little bit to the right. You see that reddish tone, and there's a transition zone there. And so we get a mixture of Wyomingensis and the mountain big sage. Finally, we get to an elevation going further east, that bluish tone. That's our mountain big sage domain. So that would be one, just to give you an idea of what this map product kind of looks like. That's what we're going to be dealing with for the rest of our talk today, is the distribution of these Artemisia species and how we did it. All right, I'm going to back up a little bit because I left out a lot of details. Number one, because I'm not a detailed person, but number two, because we were just defining the introduction components of this work. What we did is we combined our data together, the EVT, the BPS, the zone, and many of you are very, very familiar with this technique. And so we combined those maps together. Good, we've got combinations of all those on the landscape. Then we looked at the LANDFIRE reference database over those combinations and asked the reference database, give me all your Artemisia species. Artemisia whatever. So we do that. Well, there's a lot of Artemisia species that we don't necessarily concern ourselves with. For example, Artemisia ludoviciana. Not really a shrub. We're not worried about it in terms of risk. It's not a big component, let's say, of species habitat. I hope there's no Artemisia ludoviciana aficionados here, but what I'm saying is there are many species of Artemisia that we're not really that concerned with. The ones we were concerned with are the ones you just saw on the map. So when we take roughly 40,000 plots in the LANDFIRE reference database that have an Artemisia at that plot location, when we winnow it down to the ones we're interested in, it's about 15,500 plots with our target Artemisia species. Again, LANDFIRE reference database, a tremendous product. You're not going to find that anywhere else. And so we're very pleased with the fact that we got 15,000 plots, plus or minus. So we take those plots which have coordinates, we overlay them, and here's one bone to pick with the LANDFIRE reference database. Right now, it's my understanding, I talked with Brenda Lundberg, who's the expert on this topic. We do not have, at each plot location, we do not have the biophysical setting keyed at each plot to a biophysical setting. So I could be wrong about this, but that's what I was told. And that means that we did not have a biophysical settings keyed at a given plot. We didn't know what settings that plot lived on. So we had to place those plots on the map and ask the computer, within these plots, tell me from the biophysical settings map what the biophysical settings is. And I don't trust the maps as much as I trust the assignments in the database, but we don't have them. So that was one limiting factor to what we did. We simply buffered around those LANDFIRE reference database points and asked the computer to tell us the majority biophysical setting, a very simple rudimentary GIS technique. So then we got it. So now we've got, follow me here, we've got our maps that have the combinations of the EVT, the biophysical settings, and the zone on one hand. On the other hand, we have the LANDFIRE reference database that also has existing vegetation type, the zone that it lives in, and now the map sampled biophysical setting appended to that database. So now we've got kind of a one-to-one crosswalk where we can ask the computer to tell us what Artemisia species live within those biophysical settings and existing vegetation types and map zones. So that's how we did that. But then we also, remember, we also used our shrub cover to tell us for any of those combinations, are there really shrubs there on the map, for example? Are there really, we know in the database because they're data points, but maybe those points have burned since they were taken. So there's no longer shrubs there. So that's why we relied on an extraneous source of shrub cover to tell us if there was really shrubs on the map or not. And I hope this makes sense. We can talk about it more if it doesn't. Okay, what I've done in this next to final slide before we go into a map and can drill down and ask questions of different areas, I tried to color the species to give you separation for you to absorb what the final product is. And for those of you that know the Great Basin, I'm sure you can throw darts and we can talk about these characteristics. Part of the reason you see the patterns that you do of these different Artemisia species, it's all because of the data. So whatever was in the data in the LANDFIRE reference database, it's going to be represented here. If it's not in there, we don't see it. Now, I want to also talk a little bit about the mixed issue. Let's say you have 100 plots that have Artemisia nova, 100 plots that have Artemisia tridentata bassiana, and then Wyoming ensis. So it's an equal mix of the three. Maybe that wouldn't happen. It's just an example. So we've got 300 plots mixed equally between three different species, all supposedly occupying the same site, the same EVT, the same biophysical setting, and the same map zone. How do you deal with that? I don't know. You either get a better mapping technique or you live with the fact that they are mixed. But here's how we dealt with it. What we decided was, remember the goal of the project was to evaluate risk. So in the case, let's go back to our example. In the case of, we've got a Wyoming ensis there, we've got a black sagebrush there, and then we have a mountain sagebrush there. Well, mountain sagebrush tends to be pretty resilient, you know, because of the cool and mesic conditions it exists under, so we're not that worried about it. So what we're going to do of those three, let's just say we thought black sagebrush was the most at risk if there was disturbance to that site. So in that case, we would say, okay, even though they're mixed, we're going to say to err on the side of caution that we think it's dominated by black sagebrush. So we want to avoid treatments in those areas that would be detrimental to those sometimes rather fragile sites that black sagebrush Artemisia nova represents. Does this make sense or not? And of course, no one has their camera on, so I guess you're nodding, and I hope you're not shaking your head, but we can talk more about this. What I want to do is go to the database. So let's open an Excel file briefly and look at the complexity of this. So here we go. Let's go into our directory here, and I'm going to pull up the demo spreadsheet, and we're going to look at everything mushed together so that it kind of make a little more sense in your head, I hope. Remember, we had biophysical settings as part of our combination. And we had, let's go over, we had existing vegetation type, which is here. We had our biophysical settings, which is here. And we have our LANDFIRE map zone, which is here. When we query the LANDFIRE reference database, take a look
Hey,
at
Matt,
this
are
great, go
are
ahead.
are you thinking we're looking at your database right now? Because I'm still seeing the PowerPoint.
That Zoom issue. Yeah,
Yeah,
hold on. What
I
I'm
think
going
it
to need to do is
was,
stop share and share
yeah,
the spreadsheet. Sorry
no
about that.
worries.
I'm glad you said something.
That's okay.
Just babbling into thin air doesn't help anybody.
Oh, no.
All right,
I
share the
knew.
screen.
We'll get back on track.
Yeah, like I said, Teams seems to do better with multi-sharing. I don't know. Now, can you see the spreadsheet?
Got it.
All right. So again, thank you for catching that. So we have existing vegetation type in the highlighted column. We have our biophysical settings here. And then we have our map zone here. And you could add layers if you wanted to your combine until you get way down. I mean, you can do whatever, but this is what we did. But look at this, it's very curious. On this particular combination, Great Basin xeric mixed sagebrush shrubland, it's both the EBT and the BPS. So the existing plus the site potential is the same. We had 444 plots that were R04, which is black sagebrush. Oh, goody. So we take this combination in our database and we find where those combinations exist on the map, and voila, it gets R04 or black sagebrush. So this combination would be mapped as a black sagebrush site. One down. We have another one that's the same site, the same EVT, but look, the map zone has changed. We were map zone 17, but in map zone 12, we had a mixture. We had the black sagebrush here, 334 plots of black sagebrush, and we had 104 plots of Artemisia arbuscula or low sagebrush. So it's mixed, but it's predominantly black sagebrush. And again, you'll remember how I said we dealt with the mixtures, and that was, we said which of these sagebrush species is most probably at risk when we consider disturbance. And so that one would get, you can see, you scroll over here, it gets a map code of a 1, which is black sagebrush. And all of these down to here are all black sagebrush because I sorted based on this column here, which tells us the number of plots of black sagebrush. So those of you that do this a lot, I think, can see exactly what we did here. It is not complicated. It's pretty basic. And there are many ways of improving on this.
Hey, Matt.
Now, yeah.
Before we move on, Louis had a question. Louis, would you mind asking it? You want to unmute yourself and just ask?
Actually,
well, it had to do with the previous slide before getting, I actually had questions about that. So in the slides, you showed pink areas in the valleys of the Great Basin that were tridentata wyomingensis and tridentata, so basin big sage. Now, the question was, are you saying those species are found there, but in reality, most of those valley bottoms are not sagebrush, they're greasewood or they're salt desert. So you map them as if they were sagebrush communities, but a large proportion of that is actually not sagebrush at all. Whereas the Reno area was no sagebrush, and both Megan and I live there, and we know very well there's plenty of sagebrush. So I'm kind of confused about what the map is really saying.
The map, all the map is, Louis, is just the, I think you know exactly the combination of factors that we used here. And if the plots did not, if the plots, what we could do to, and this is step number 1, but what you can do to override the fact that those valley bottoms had plots in them with sagebrush. So we could override that and just say, look, yes, we see plots in the LANDFIRE reference database on that BPS, on that EVT, and that map zone that had sagebrush occurring. We could say, yeah, that's all fine, but because of Louis' idea, why don't we instead ask, is there a higher proportion of other species there other than sagebrush. And you're exactly right. So for example, we could say there might have been 50 plots that had an Artemisia species represented, but then you could flip it on its head and say, yeah, that's fine. Just tell me the most common characteristics of those biophysical settings in EVT, which might have been greasewood, et cetera. And you, for example, you might find that 1,000 plots were greasewood and only 50 plots had sagebrush in them. Then you could say, well, that's all fine. I think that the map that we see here. So you can stack those kinds of assumptions on there to, as you begin to learn more about the map, as you have said, and kind of override that the initial kind of assumptions that we did, where is there sagebrush represented in the Landfire reference database at these locations? Yes or no? And how many plots were represented of the different species? So you could layer one more assumption on there that would say, yeah, it's just greasewood or whatever.
Yeah, I think in this case, the plot values are misleading you. The actual BPS from Landfire would be more accurate than a survey of the existing plots, because typically the BLM collects the data, or the others go to the sagebrush systems where the cows graze, but they don't go to greasewood to measure things or other things, or salt desert. It's not their, they put their plots in their more productive system because of livestock operations. So that this is where I'm kind of, that's my question, is something's steering you towards sagebrush over representation in areas where there's practically no sagebrush. And you have
that's
no
right.
So
yeah,
that's
right.
That's what's puzzling me. So now I understand.
Yeah, and it is not, as you have identified, it's not a probabilistic effort, because, well, the LMF is, as you know, Louis, from AIM, but not the project-specific data from the BLM. The LMF would give us a probabilistic viewpoint of that, and you could limit your evaluation to those plots, but now you're down to what, 5,000 plots for the whole kit and caboodle, something like that.
Okay, thank you.
But yeah, what we're going to do next is take this initial cut of what these plots tell us and what they don't tell us, and then begin to take slices, as you've said, Louis, about, you know, next slice is, are there even shrubs there? Or did they all burn off, or something else happened to them? Yes or no? Then is it really a shrub system, or do we find annual grass there now? Or using this information, do we think that greasewood is totally overriding the whole thing? So you begin to layer on some of these assumptions. And you've studied BPS a lot, and you have a very good feel for the pluses and minuses in your area. I know this. But I don't know that just using BPS is better than some other types of approaches. Maybe it is, but I don't know. Maybe we could use BPS and then start with that, and then layer on the other assumptions. Is there annual grass there now? Is there not sagebrush and instead greasewood? So maybe there's a way of just going with that. But I don't know. It'd be an interesting comparison.
Thank you.
Thanks,
Okay.
Louis. Hey, Matt,
Yeah,
if
you.
If it's okay with you, would you mind fielding another question from Lee?
No, go ahead. I see Lee Davis in the chat.
All right, Lee, do you want to unmute yourself and ask, or do you want me to read it?
Oh, hey, I didn't actually have a question. It was just
okay. Okay. All right. And just to make sure we have enough time to answer questions at the end, Matt, do you want to maybe say a couple of final things, and then we'll make sure we have time to hear from folks at the end?
I've said enough. Why don't we just field questions? It's more useful.
Okay. Sounds like we have some people in the audience that might be having some questions, not necessarily related to Matt's work. General Landfire questions, we're happy to field those. We have tons of experts on the call. I know Henry was going to say something about LF2020. So if we don't have anybody volunteer right away, we can have him do that. Louis, did you have
another
else?
question?
Yeah, go for it.
In the database, Matt, that you were showing, something that surprised me a little bit. So you had, there was the Intermountain Basin big sagebrush, which is a classic Wyoming. But you said there was a majority of plot that were black sagebrush. And the question is, why? If there is, this was the database, if if I see Intermountain big sagebrush, it was like the last Intermountain, yeah.
Can you see
Intermountain
my
Basin
screen, Louis? Can you see
Yes.
the screen?
Yep, we
Yeah.
got it.
Okay.
That one, yes, that one, it was lower down. It was Intermountain Basin big sage, and you said you had a preponderance of black sagebrush. So the question to the LANDFIRE folks is, why was that ever considered Intermountain big sagebrush and not, dwarf sagebrush system? So that's the question. Why would someone interpret Intermountain Basin big sagebrush, which is your classic Wyoming sagebrush BPS? Why would that ever be pigeonholed as black sagebrush is beyond me. So this is the question. Why can that happen at all? That's mysterious to me. That's very mysterious.
Good question, Louis.
That's an error. There's an error there somewhere, because that is by definition wrong. So that row cannot be true. It's either Wyoming or a big sagebrush, but it's not black sagebrush. So it's either there's a pixel resolution issue, it's a very heterogeneous landscape with both systems are commingled or something like that, but it would never have been called big sagebrush. It was dominated by black sagebrush. It just can't be. So
Well, I think one thing that's confusing is you see there's an 80-20 split here. So 80%, 84 plots of the Arter W8 and Arter 2, which would be Wyomingensis and Basin big sagebrush. So it's by far dominated by, as you had said, Wyomingensis and Tridentata. But because there are 20 plots there of black sagebrush, we said, when we have these mixtures, and you could play games with the proportions that you want to, how you want to split it. But remember, we said if there's a chance, either way, these are highly invasible sites. They're pretty invasible, low resistance, low resilience, and whether or not they're called Arno 4 in this case, which we did because it's the weaker of the two based on the site characteristics that black sagebrush is supposed to occur in. That's part of what's making it difficult to understand is you could code this and we could call it Arter W. So just put a 2 in there. Now we got an Arter W on the map there. Either way, the system is going to know. Keep in mind the end goal here. There's some flexibility in how you do this, because in the end, that site, whether it's a 1 or a 2, we're going to know these are pretty wimpy sites. And if we go in there and start doing stuff, you go in there, let's just say something absurd like chaining it or something, you do some prescribed fire at the wrong time and it just goes crazy. That's a bad decision. So either if it's a 1 or a 2, it won't matter. It'll still get the same result when it goes to Forces, which says this is where we don't want to be messing with the landscape too much.
okay, that
I hope
helps.
that made sense.
Yeah, I hope that, yeah, but yes, what caught my attention is that it was being called a different system, and that was, now, as you folks may know, if you go, for example, to Ely, Nevada, and you take a 30-meter pixel because of the wash systems coming down, the alluvial fans and all that, you will have side-by-side black sagebrush and Wyoming sagebrush in the convex concave slopes. They just alternate within a 30-meter pixel consistently. But we map them at 30-meter resolution. You just can't capture that very well. And I suspect that's the problem that's happening right there. If you're working at 5-meter pixel, at 1.5-meter pixel, you will see that at 30-meter pixel, you'll probably be picking up both systems. And I'm wondering if that's what's happening too. So we map them when we do our routes, we map them as totally distinct. But here there's Ward Mountain's a good example of this. Within 20 feet, you go from pure black sagebrush to pure Wyoming. One's in deep soil, one's in shallow soil. So,
well, and keep in mind that, remember I said that unfortunately the LANDFIRE reference database does not have the BPS keyed in there. We had to play the pixel game, Louis. We put the plots on there.
okay.
What BPS are we at? And so it's breaking down there as well. If it were keyed,
Okay.
these results would be different, as you can see.
Okay.
That's a bit advanced, but I hope people could understand what Louis and I were talking about.
Yeah. Mike, did you have something to say?
Just had a clarification question. That's really helpful, Matt. And So it seems like what was confusing there was an 80-20 split and you were classifying it as black sage to sort of be on the safe side. So my question is, what proportion, how low are you going? Is it, if it's at least 20%, at least 10% to classify as black sage, what's kind of the low cutoff you're using?
Well, the answer is I don't remember, because Jean Chambers took this and worked on it for about a month, and well, not a month. She worked on it for a few days to play with different thresholds, and I just don't remember what the thresholds would be, because your thresholds, this is way more art than science, I hate to say, but your thresholds for your end game characteristics will be different than my thresholds. Again, we want to identify places that we don't want to be doing certain kinds of treatments, and we're erring on the side of caution. So that suggests maybe you wouldn't care about that for your purposes. And for your purposes, maybe you wanted to find Wyoming big sagebrush. So you would say, show me anything that's 50-50, because I think it's flipping a coin and I'm okay with that. So I don't know our thresholds. Jean has that and sent them to me in a final product, which I mapped, but your thresholds would probably be different for your project. I hope that helps.
Yeah, thanks.
Who's next? Henry, did you want to go?
Sure. Matt, could you talk a little bit more, the way you framed this and tee this up is this is going to support a risk assessment. And so we quickly dived down into the weeds on the sagebrush, but can you talk a little bit more to the entities or groups that are working on this? And again, it looked like it was just focused specifically for what I'll call the Great Basin area. And if you can provide some context of why just that focus, narrow focus, versus the larger distribution of where sagebrush occurs across the Intermountain West, that would be helpful.
The administrative answer is, Henry, we don't, I believe that they limited that study area to the Great Basin from the larger study area that I showed, because of constraints using FSIM, not that it couldn't do it, but that we felt like the resources would allow us to do something like the Great Basin. So that's an administrative answer. I don't have a scientific answer for it. And that's not my domain. I was asked to provide support for the fuel bed properties associated with post-fire characteristics. And that's my tranche of the study. I wish I could speak more to that, but I can't.
Okay, that's helpful. Thank you.
Yeah, you had another part to your question or not? I can't remember, Henry.
It was just the greater extent, that because we're focusing this just on the Great Basin, recognizing that sagebrush, goes across the entire West. When I think about, again, habitat, as you described at the beginning, this is not just a phenomenon that is affecting the Great Basin. Risk is, across a much larger area. Yeah.
Yeah, and a starting point linking all these systems together would be the Great Basin. I'm sure once we learn our mistakes from this, it would be nothing at all to expand to what you see here. The key issue is bringing forces in here to help us decide, kind of for the first time in these non-forest systems, what shape, length, and size of treatments would be most beneficial given expected fire behavior and where the values at risk are.
Okay, thank you, Matt.
Hi, Mike, you have your hand up there, I see.
I was curious if you know of any good data sets. I mean, so you mentioned that you included existing shrub cover and that there's a few options there. I'm curious if you know of any good options for existing understory data that could be potentially incorporated into this.
Understory data is vexing, and if we're talking about forests, no. Beyond FIA, I'm not aware of widespread efforts to do this forest inventory analysis. The NRI, National Resources Inventory, has some, but FIA is probably the best bet, but it's very sparse on a 3-kilometer grid, as you know, probably across the United States. The understory is a real stinker. We just completed a wild horse and burro capacity assessment on the border of Nevada and California. And that's one of the major issues that we're going to continue to struggle with. So to answer your question, maybe someone else knows of a good understory data set, but they're few and far between.
If anyone's on the call, then feel free to chime in if you do know of a good understory data set. Henry was going to say something about LANDFIRE 2020. As he's doing that, I'm going to launch a quick poll to evaluate our office hours. So please minimize it if you don't want to take it right now, but make sure you take it before you head out for today. And yeah, go ahead, Henry.
Perfect. So yeah, just maybe a brief update. We're really excited. Megan actually kicked this off at the beginning, but we're really excited with the LANDFIRE 2020 products that are coming off the production conveyor belt, so to speak. So most of CONUS was completed, with delivery the first part of June. Right here at the end of June, we will have Alaska as well as the Northeast being completed. And then coming into the month of July, the rest of 2020 with Hawaii and Puerto Rico, that will be completed as well and available. So we're really excited about that. This is, again, another step towards being able to meet that desire to have an annual product. And so next year, I think we will be positioning ourselves even closer to that annual goal. And the goal is to produce a LANDFIRE 2022 product that would be available, again, kind of like we're seeing this year, staged out over a course of a few months as we look at that year. And of course, the key thing with all this is it's going to be based off of, just as Matt has already shared, input data drives everything. So we are leveraging a lot of authoritative systems of record, things like the Forest Service FACS database, NIFPORs within the Department of Interior, a number of other things like that. So as long as folks are getting their data into those places, that's great. If they're not, then we need to, make sure that that data is submitted to Brenda Lundberg so that it can be incorporated. And happy to talk more about that, but I think I'll stop there and leave the balance of time for some other questions.
Yeah, if anyone has specific questions for Henry, certainly open to hearing them. Yeah, Louis, go for it.
It was a question for Matt. Something I want to make sure I understand, because although I should be more familiar with the LANDFIRE data sets and all that, we do our own remote sensing, so this is why I don't rely so much on it. But Matt, you were mentioning something about, you mentioned it twice, the LANDFIRE data is not georeferenced to something or what? Can you explain that? Because I'm not sure I understand what exactly you mean. And you may have to do 5th grade explanation to make sure that I understand what you meant by that. You said one of the limitations of blah, blah, and I'm not sure I understand what you meant. That it sounded pretty basic, and I can't believe that's not part of the LANDFIRE data.
Okay, so.
And 5th grade.
We have plots in the LANDFIRE reference database. They're points on the ground, as you know. And so we know what the characteristics are of the site, the soils, the slope, the aspect, elevation, all these things, supposedly. And we know because of the survey what the floristics were, because people sampled it. Using that information, the LANDFIRE reference database has a set of sequence tables or algorithms that can determine, and people can jump in here if I'm way off, but they can determine what the existing vegetation type is in terms of ecological systems. So what kind of ecological system is it based on all that stuff? They did not do that, it's my understanding, in this version for the biophysical settings. So we know what the existing is because it was classified from the plot data, but not the site potential, the biophysical settings. So that's when I said, right, plots are key to EVT, not BPS, right? So now we've got a quandary because, well, what BPS does the plot live on? Well, I don't know. We have to sample the map to find out. I have no other way of determining that. And that leads to error, as you can see, because you're relying on the map, a 100-meter buffer around the point What are the pixels like? Well, it's Intermountain Basin, big sagebrush, 80%. Okay, there you go. That's what it is. So that's what we did, and that's why I think that's a source of confusion and error in the process, but I don't have a better angle for it. It'd be nice if they had those sequence tables to classify the BPS automatically, but they don't.
So I could just add maybe a little bit there. Plots are not, for the most part, especially in the West, used to map biophysical setting, but things like soil aspect, elevation, precip, growing degree days. So those are the factors that we use to map biophysical setting. But it's an interesting idea, having seen this, you know, it does highlight some potential issues, and it could be a way maybe to do some local rectification of your biophysical settings map.
Part of the reason for this is, for those on the call, if you use your existing data, your existing vegetation to inform potential, now all of a sudden you have clear cuts in your biophysical settings, your pre-Euro-American settlement depiction of conditions, and that would not be right either. So you got to be careful when you do that. You'll end up with weirdness.
Thanks, Matt. Thanks, Corey. Thanks, Louie. Any final questions before we sign off for today? We still have 5 minutes.
Hey, Matt, Randy here. I did a conceptually similar project with mycorrhizae, actually, where we had a spreadsheet very similar to the one you showed. And I very much appreciate the challenge of assigning a value when you have multiple, for example, sagebrush types in the same thing. So it makes you want sliders or something, doesn't it? Where the user could slide those thresholds along and see how things change. But I just wanted to note, I very much appreciate the challenge and the art of what you're doing. Now, I see Henry has his hand up.
Yeah, so just maybe a follow-up question, Matt. Again, risk is key to everything that we are doing in a number of ways. And of course, there's a number of risk assessments being done, you know, across different geographic areas. So could you just speak to maybe the timeline that this particular effort is, you know, at least planned for, and when we might expect the final results?
We'll have results. This is a plus or minus 4-year project. We're at year 2. We'll have results in a year to share and finalized in probably 1.5 to 2 years. The project, again, the University of Nevada, the BLM, of course, the Forest Service, a lot of research station folks, all in when we have our calls. Oh, and including Pyrologics was a big partner, helping calibrate the fuels for this area. And now also, you know, Alan Ager's group is involved. So it's quite an interweaved process with some additions, Henry, that University of Nevada, Reno is supplying a lot of the economic considerations to fuel treatments and understanding, you know, if we have $1 billion to spend, how would we spend it to get the biggest bang for the buck? So they're adding some, you know, there are a lot of risk assessments out there, a lot being done. I think some of the unique components would be on that economic part of it, rather than just overlaying the fire behavior with whatever. So there's some more careful thought with respect to economics in this study.
Perfect. That's super helpful, Matt. And we'll definitely want to coordinate with, I think, certain aspects of this as it moves forward. Really exciting. Again, appreciate your work and your time on this.
Yeah, one thing that probably didn't come through very much, I encourage folks to consider looking at the Sage Step chrono sequences of treatment effects. So they went and they burned and monitored for 15 years. They went and they sprayed and they monitored for 15 years. They went, and now we have actually some cattle studies going on at University of Nevada, Reno, looking at cheatgrass depletion, et cetera. So Sage Step is a truly wonderful resource, as is LANDFIRE.
Oh, I was just going to say that Brenda does have the post-disturbance plot data from the Sage Step project now, and is incorporating that into our LFRDB as well. So so there's a good exchange there. But yeah, I was just going to emphasize the fact that that we don't there's really no relationship between the LFRDB and BPS at this point. So it's purely used to map existing vegetation.